Hello, fifth graders. We are excited to share with you some information about counting outcomes. This is in chapter 15, lesson 4, and you can find information about that on page 677. And we are going to use something called a diagram tree to help us solve some of these problems. So today we will list outcomes of a probability experiment. One of the vocabulary words that we will talk about and actually use to solve the problems is diagram tree. All right, so now they're going to give us this scenario. It says 4 of the coasters at Wonderland Park are Tornado, Free Fall, Big Coaster, and Cyclone. 2 of the water rides are Thunder, Jet Racer, and Shoot the Chute. Make a tree diagram to show all of the possible 2-ride combinations if a person rides a coaster first and then a water ride. Now, first of all, I am going to say that you're not going to catch me on any of these rides, but if we're going to solve this problem and use a diagram tree, this is how we would go about it. The roller coasters are, so these are the 4 roller coasters. So when you're listing it under different types of coasters, you'd say roller coaster, tornado, free fall, big coaster, and cyclone. And then, if you're listing the water rides, there were 2 water rides that were listed, the Thunder Jet Racer and the Shoot the Chute. So here are our coasters, the 4 of them listed, and then underneath the water rides, you're going to have the 2 water rides. And then you'll list the possible outcomes. This is the diagram tree. So if you said, I'm going to ride the coaster from the tornado coaster, then you would say, okay, the tornado, and then the Thunder Jet, and the tornado, and the Shoot the Chute. And then these are kind of abbreviations that they use for the outcomes. So in the free fall, that would be the same thing. So the coaster would be the free fall, the water ride, the Thunder Jet, and the Shoot the Chute. So you have 2 possible outcomes per coaster. Okay, again, the big coaster, again, you're going to have 2 possible outcomes when combined with the water ride. So if you look at that, if you're going to ride a combination of a coaster and a water ride, from that you're going to have 8 total outcomes. There is kind of a shortcut. If you look at, and you're listing these, you know that per coaster, when combined with the water rides, per coaster, you're going to have 2 outcomes. So if you have 4 different types of coasters, you're going to have 8 different outcomes. 4 times 2 would be 8. That's another way to look at it. So there are 8 possible combinations, and those are listed. Oh, we went right to this one. All right, we found the answer already. So let's look at this a little bit closer. Ted tosses a coin and spins a spinner that has 4 colors: red, yellow, blue, and green. How many possible outcomes are there for Ted when he tosses a coin and spins the spinner? So if we're going to draw a diagram tree for that, you'd look at that and you'd say, well, oops, this is not working. Go back. Mr. Bessie's going to hit the back. Usually I can write on it. I'm not sure what's going on. But if we were to look at that, particular problem, we'd have a coin, right? And then you'd have the spinner. Okay? And on that coin, you have obviously the heads or tails. Okay? And then the spinner has 4 possible colors. From the spinner, you would have red, yellow, blue, and green. And I'm going to move this tails down a little bit. So you know with the coin, if you flip the coin and then spin the spinner, you'd have the heads and red. So we list that as heads and red. You'd have the heads and yellow. Okay, you'd have the heads and blue, and then the heads in green. Okay, so from the head side alone, you have 4 different outcomes. Okay, so when you have the tail side, how many outcomes do you think you would have when you'd flip the tails first. Again, you would have 4 again. So you could look at that and you could say, well, 2 times 4 would be 8. And that's how they came about that answer using the diagram tree. On this one, it says a spinner has 3 sections of equal size, and each section is a different color. Suppose you spin a spinner 2 times. What is the probability of spinning the same color? Well, if we look at that problem, you are going to take a spinner that has the same different colors. So you would look at that and you'd have spinner 1, not a spinner, so let's say spinner, spin 1, and then spin 2. Okay, the first time that you'd spin it, you'd have a red, a blue, and a green. Okay, so if you spun the first spinner once, then a possible outcome of that would be, again, red. You could do red on the second spinner. If you spin red again, then another outcome might be blue. So you would have red, 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 blue, okay, and then red, green. Oh, look at, isn't that beautiful? Very similar to the diagram that I was drawing. So, thank you, Mr. Bessie, my assistant.
You're welcome.
We've got red, blue, green, the second spin.
Oops.
Oh,
It's jumping ahead for some
it's
reason.
jumping. So, you can see, though, how we would come up with, you've got 3 different spins, 3 possible outcomes. You'd have a total of 9 outcomes on that. So if you wanted to figure out what is the probability of spinning red, red, well there it is, where you're spinning, the question asks for the same color. So you spun blue, blue, here it is, and green, green, there it is. So out of our total of 9 possibilities, we would spin the same color 3 different times. Now, we know by looking at that, 3/9, what goes into both 9 and 3 that is the same?
3.
We would say 3. So we're going to divide by both the numerator and the denominator by 3. And so the probability of spinning the same color twice on the 2 spinners would be 1/3. Okay? So here we've got, again, 3/9. And then we simplified 3/9 because 3 goes into both 3 and 9, and we got 1/3. Okay? All right. Oh, and as luck would have it, there's more. The spinner has 3 sections of equal size. Okay? The colors of those sections are green, red, and blue. Suppose you spin the spinner 2 times. What is the probability of spinning red and then green? Okay, so we're going to spin the spinner 2 times. So we're going to have, again, if we're going to draw out this tree diagram, we're going to have spinner 1, spin 1, and spin 2. Okay, so what are our possible outcomes of the first spin? The colors that are listed are green, we've got red, and blue. Okay, so it says you spin the spinner 2 times. What's the probability of spinning red and then green? Okay, so if we were to list this spinner 2, you'd have the possible outcomes there are going to be, you would spin this one once, and then you could possibly spin a green. Okay, and then your outcome ends up being green, green, okay, or green and red. So that would be green and red, or green and blue. Okay, and then the same thing would go for the red. Now, the question asks, what's the probability of spinning red and green? Well, here you'd have red and green, red and red, and red and blue. we know our total outcomes from this. We've got 3 here, 3 here, 3 here. We know it's going to be something over 9 again. Now, when in this particular question they're saying spinning red and then green, well here's red and green, and the only time that that's going to happen is 1 out of those 9 times, because this again would be blue and green, blue and red, blue and blue. And you can see it only happens that 1 time. So the probability of spinning that would be, dun, da, 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 1/9. Okay? Whew. Boys and girls, you are doing so well. And please, as we've said before, if you have any questions, please feel free to reach out and contact one of us. But we hope that you and your family are doing well. Thank you.